Hey everyone, I wanted to show you guys how to do the Google Maps area project. Okay, first of all, make sure you change the theme, the name, and all this of your project, because this is just white and black and boring. So, general idea is we're going to find the square footage of a plot of land, a house, or some other area that interests you and can be easily seen on Google Earth. I put the rubric in here so you can see what is required and how many points you'll get on each slide for that. And so the general idea is you're going to first take a screenshot of what you want to find. Don't pick a rectangular area because rectangles are just length times width. We're trying to find an area that you can break into triangles and use trig to find that you otherwise would not be able to find. Once you have a screenshot, you're going to copy it here and you're going to break it into triangles. You need at least 5 triangles for 100% of the project, but of course the more the merrier. Be careful, don't go overboard on this because each triangle takes a bit of work to do. So you put in too many triangles, you'll be doing a lot of work. Then you're going to copy the previous page, just real quick. When you right click, you can go to duplicate slide. So anytime you want to copy a slide, you just duplicate the slide and it copies all the things you wrote on the previous slide. You want to find the length of enough of the lines and type them into this page, and you can use the appropriate law to find all the areas. You should be using the law of sines and the law of cosines just to show that you know both. And we'll look at examples of that. So last, you'll show your work to find the area for each triangle created, and you'll add up all the areas and convert it into acres to see how many acres. And you may use the internet to convert. It's as simple as typing in 3,000 square feet equals a certain number of acres. So first I want to show you guys, let's go over to Google Maps, maps.google.com, and I want to show you guys how to find the area of, or so not the area, the length of a certain thing. So let me zoom out. I need to come in here to Walkersville, and let's say I want to find maybe the area of the high school and elementary school combined. That would be a good one. Don't do that one because that's obviously my example here. But what you're going to do is you're going to right-click on one of the vertices, one of the corners. So let's right-click on this corner right here. And you want to find measure distance. Okay? Once you click that, it's got a dot, and you'll make another dot right on the next vertex. Okay? You just click with your left mouse click. Now you can keep going and click all around, but don't do that because it doesn't tell you the distance from the first dot to the second dot. You really need that distance because it just tells you the total distance. So to remove a dot, you click on that, and what we're going to do, we're going to do leapfrogging. Here's how you leapfrog. So see, it tells you the distance down here, 665.69 feet, which is really, really specific. You know, that's saying a fraction of a foot it can measure. It's pretty impressive. So I have this one, then I'm going to grab the first one, just kind of leapfrog it over and get the next distance. So, you know, that number changed, so 1,223. And if you click and do a bunch of them, it won't do that leapfrog distance, so you kind of need that. You can choose how exact you want to be. The more vertices you have, the more triangles you'll get. Remember, you need at least 5 triangles. 1,169, see, so and you just kind of leapfrog over, make sure you're recording these, write these down, screenshot and mark them like you'll see here in a second. Once you get all these nodes, see this right here on this curve, you can choose to skip over it, kind of average it. I might do 2 increments, so there's 1, write that one down, then there's a second, write that one down. But you need more than just the perimeter. You also need lengths in the middle. So once you have it marked down, you'll then want to make sure, it's a good idea to choose points that are easy to find again, like this one here in the middle. You kind of eyeball it. I really wish I had picked a point that I could see more easily. Because you need this distance, this distance, this distance, and this distance, right? And all of those in order to get those, depending on how I draw the triangles. So let me show you guys some examples. That's how you get the area, the lengths there. Here are 3 examples of good projects. So Google Maps area project. This person left the rubric on, which is great. They had a picture. They wanted to do Pine Lake, Australia. See, they found, they kind of marked theirs out. You can do that if you want to, or you can just mark it in Google. And they put letters around, see, A through K, and each of these line segments, so line segment A, B is this, B, C is that, you know, A, C, A, D. They chose to radiate all from a single point, which works. And then they went on, and each of these parts, they then used law of cosines, to find the third angle, or one angle, and then they used the sine area formula, 1/2 AB sine C, to find the area of that one. right? So you use law of cosines to find an angle, sine area formula to find the area. And they went and did that for each of them, right? And so notice they did use law of sines to find one of the angles, which I require. But then, yeah, they use the area formula, law of cosines, area formula, all the way down. And I'll share a link to these example projects because they're very good examples. There's a lot of typing that you can do with this. So notice at the end that they have the square mileage. So they measured all their things in miles. If you notice back here when you're on the maps, oops, it can be down here in meters, or you can just convert that to miles, right? If it's in terms of feet. If it's a large distance, I guess it measures in miles instead, yeah. The square miles, you just literally type into Google 3.57 square miles, convert to acres, and it will convert it for you, okay? But I still want you to do that and find about how many acres it is. If you would rather write a lot of this on paper, here's an example of a student that did the University of Colorado. And see, they got their picture and they outlined it and they labeled all the distances directly on there, which I like a lot, but either way works. And then they started working. So you notice that this person was very organized. They showed which triangle they're working on, and they wrote out their work. They knew it's a lot of work to write out, so they decided they'd rather write it. They'd rather write it rather than type it, and that is just fine. So see, they find all those angles, make sure it checks out, and they did that for each of them. You notice the blue triangle moves around, and they have labeled A, B, and C each time to match their work with A, B, and C. You could use that, or you can use like the previous student had the different letters, right? Found the areas of all the triangles, and then found the acreage by adding up all the acres. So she made an estimation ahead of time. Here's a third example, okay? Did the Palm Jumeirah. This is in Dubai. I've never seen this. This is a man-made island that was designed to maximize the beachfront property, right? So you can picture do that. That's what you would do. I gave them the permission instead of having to do a billion triangles, just find this entire area. And they did similar to the first student. Notice they had the area and the law of cosines on each side, going all the way down. So these are three examples of three excellent projects. And she also did more. She also wanted to do the base down here, the trunk of the tree, the palm tree, and found that area and found the total area. Okay, so and yeah, included a fun fact, which is pretty cool. So yeah, you go ahead and you get started. Notice that in the agenda there are different stages I'd like to for you to have be done by, and you can message me or I will check these in class as you go. And please reach out and ask questions if you have any. Thank you very much for watching.